Use Newton's method to find all solutions of the equation correct to 6 decimals. We'll start by putting both terms on the same side so that we can think of this as a function f of x. Cosine of 2x minus x cubed. In order to use Newton's method, we then need f prime. The derivative is negative 2 sine of 2x minus 3x squared. Next, we can graph f cosine of 2x minus x cubed. Looking at the graph, we can see that it looks like the 0 is around 1. So let's let x sub 1, our first approximation, be 1. Recall the formula for Newton's method. X sub n plus 1 is equal to x sub n minus f of x sub n divided by f prime of x sub n. So if we are looking for the second approximation, we would take 1 minus f of 1 divided by f prime of 1. Now we can do this relatively quickly in the calculator. Since we're looking for 6 decimal places of accuracy, let's go to the home screen on the calculator, and we're going to store our starting value 1 in a letter. You can put it in any letter you want. I'm going to store 1 in alpha A and hit enter. So now we have that 1 is stored in the letter A. So now we'll use Newton's method, and we're going to use the generic value that we started with, alpha A minus, we'll get a fraction to make it look a little bit neater. Now we want to type in f of A. So we have cosine of 2 times A minus A cubed. And in the denominator, we want to type in f prime and input A. We have negative 2 sine of 2 times A minus 3 times A squared. And before we hit enter, we want to have the calculator take this new value and store it in A. So we're going to go to store alpha A and hit enter. And notice it's going to give us the second approximation of our root. So we have 0.7061079,257. And we can hit enter again, and the calculator will give us the next approximation, since it's going to take the new A value and put it into the previous equation. So our next approximation, x3, is 0.6501704,369. That is not the same as the previous, so we're going to try it again, and keep in mind we're looking for 6 decimals of accuracy. So x sub 4, we get 0.6477699,325. Enter again, and we get x sub 5, the fifth approximation. Here we have 0.647765,4335. We're getting much closer now. Again, we want 6 decimals. So make sure to look at the 6 decimals. We're not quite there yet. They're not repeating, so enter one more time. X sub 6, we get 0.64776543335. Notice that that's actually the same as the last one. So we definitely have 6 decimals of accuracy. So the solution, correct to 6 decimals, is what we just found.